Okay, next, we're going to install the software that we're going to use. We're going to start with R&R Studio. Some of you were in data management, you installed, but to be fair, some people were not there, so we're going to install this software again. So if you go to Google Drive, you're going to get two files, a PDF file for installing R&R Studio and a PDF file for installing QGIS. So we're going to spend some time installing those two software. If you already have them, that's okay because some of you attended the data management course. But those who are new, I would like them to go to this folder, to this Google folder, and you have two files. One is called install_r_rstudio.pdf. That will give you instruction of installing R and R Studio on your computer. And the second file is called install_qgis.pdf. That will give you instruction on how to install QGIS. So this is going to take a little bit longer. So we're going to give you at least 15 minutes. And then if you're done with that, then we'll go ahead and start our training for today. But did we manage to get those two files? And how the installation going? Put yes in the chat if you managed to get the files and the installation is going okay.
Yeah, this is very fine. We have managed to install.
No, imekubali. PC ata connect.
So I'm going to give another 3 minutes, then I'm going to start. We'll still continue installing, but I'll start the lecture in 3 minutes. Okay?
Jeez. Happy. EQGIS. Ndio inatumia utengenezaji mara 8 sasa.
Okay, so we're going to start. So our module today is data science. So I'm going to start with what's data science. So data science is a data-driven, you have to have data. That's why it's called data science. It is interdisciplinary field, so it brings different areas. And what it does is focus on extracting knowledge and insight from data. So to do data science, you need to have data. At least you have to have knowledge of these different areas. And what it does, it extracts insights and knowledge from the data. So it doesn't depend, it doesn't matter what type of data. So when we did, when Peace last 2 weeks ago talked about data management, she mentioned different type of data. So you can extract data from, you can extract information from unstructured data, structured data, text, video, you name it. But at the core of data science is analytics. Without analytics, you will never do data science. So what's analytics? So analytics powers data science to transform the raw data into action. So there are 4 types of analytics. You have descriptive analytics, which we're going to see later in the detail. You have diagnostics analytics. You have predictive analytics, specific analytics, and recently we have now generative artificial intelligence that came recently, which is in brief is called GenAI. So data science is run by this analytics. So you have descriptive analytics, diagnostic analytics, predictive analytics, prescriptive analytics, and recently we have GenAI. So this week, we're going to go through data science and we're going to cover all these analytics. So anybody's talking about data science is basically, it's powered by analytics, okay? So to achieve this, data science draw from multiple disciplines. So this includes statistics. So what does statistics do? Statistics help data science in this understanding patterns and the distributions. So when you are doing data science, you have to at least understand statistics, at least the basic of statistics, because it's going to help you understand what the patterns, the distributions are. And then you need computer science. So computer science will help you manage and process all the data and also scale the workflow. So we have to deal with codings that we're going to work with later. Mathematics, you have to know modeling relationships and or to optimize outcomes. So you have to know some part of mathematics to do data science. And then artificial intelligence and machine learning. So this helps to automate the insight generation and the prediction. And then the most important that people always leave out is domain expert. You can do whatever you want to do in data science, but if you don't have the domain expert to help you conceptualize what you have gone through, then whatever you have come through or you have got, it will not help. For example, we work with different organizations. We did some work with the Uganda Revenue Authority, but we had to have domain experts, people who know about taxes, people who know about domestic revenue. Work with human resource in Brazil. We had to work with them so that they can help us. We work with CADESAS in Botswana, those who are agriculture. We work with health in Mali. So you have to have domain experts to work with you. So they're the core. They're the consumers. So whenever you're doing data science, you have domain experts to help you to make sure that what you're working on can be put in practice. So data science, you need this. You need at least knowledge of statistics, knowledge of computer science, mathematics, artificial intelligence, machine learning, but the most important is domain experts. So as a data scientist, you can work with any data. It's different with bioinformatics, which we're going to cover bioinformatics in 2 weeks. Bioinformatics is mainly for biological knowledge. You have to, we're mainly dealing with people in biology, for example, breeders, geneticists, or health. But in data science, where there's data, you can work with data science. But you need domain expertise in that particular field to help you so that you can be successful. Okay? So what are requirements for data science? Strong foundation in quantitative skills, as I already mentioned, that statistics, mathematics, econometrics, biometry. Preferences in tools like programming language, example, R, RStudio, Python, the rest, and we're going to use here R and RStudio. Ability to work with domain experts so that they can help you to consolidate understanding. Problem solving, analytical thinking, because you're going to deal with different domain experts. You can this week you're going to work with somebody in human resource, next week you're going to work with somebody in health, the other week in, so you have to make sure that you have the problem-solving thinking, and then you have to know data manipulation, visualization, and modeling skills. So in the next 5 days, we're going to go through this. We're going to go through data manipulation, visualization, and we're going to go through modeling. So this is a requirement for data science. Strong foundation in quantitative skills, proficiency in tools in programming languages, ability to work with domain experts, problem-solving, analytical thinking, and data manipulation, visualization, and modeling skills. So the tools we're going to use for this webinar, we're going to use RNR Studio that some of you installed 2 weeks ago and you're installing now. We're going to use QGIS that we also used 2 weeks ago. We're going to introduce RShiny. That's going to be for the deployment. So today, you're going to install RNR Studio and QGIS. RShine we might either install on Thursday or on Friday, depending on how things will be. But these are the tools we're going to use for this webinar. So if you haven't installed or in installing them, the first two, at least by the end of today, if you're coming back tomorrow, you should have them installed, okay? Okay, so I'm going to spend time now going through analytics, the core of data science, what powers really data science. I'm going to talk about all the four, and then I'll also talk about generative AI, okay? So what's analytics basically? Analytics allows us to derive value from data by answering 4 key questions. The first one is what happened? The second one is why did it happen? Third one is what's happening now or what might happen. And the first one is what might happen in the future. So this is basically data science. So in other words, analytics is a process by which you take your raw materials, which is data, and convert it to relevant insights that can inform organization, improve performance, and guide strategy. So this is the core of data science. So what happened? Why did it happen? What's happening now? What might happen? What might happen in the future? So in other ways, analytics is basically, it's the process where you're going to take that raw material, which is that your data, convert it into relevant insights that can inform organization, for example, breeders or people in success to improve their performance and get their strategy. Okay. So what's the benefit of analytics? So if you transform the raw data into action, it will help organization optimize resources. You're going to reduce inefficiencies, improve performances, and focus future outcomes. So what we're going to do this week, our main goals are these 4. You want to optimize your resources using data. You want to reduce inefficiencies, want to improve performance, and want to focus future outcomes. Okay? So, descriptive analytics, it answers the question, what happened? That's the first part of analytics. It's a part of data science. So it summarizes historical data to understand what happened over time. So when you're talking descriptive analytics, it asks the question, what happened? For example, let's take agriculture. In agriculture, this analytics could be involved tracking yield trend, or update soil nutrients level, or rainfall patterns, or pest season across season. So for example, you have this data, you take the average maybe of the yield. That is going to be descriptive analytics. And the question will be what happened, okay? So well, if you take the trend of rainfall, maybe the last 10 years, and you get the pattern, that answers your question, what happened? Of pest incidents across season. For example, locusts, sometimes they come after every maybe 3 to 4 to 5 years. So that's the descriptive analytics asks you question, what happened? Okay, so that always went to this example, you do averages, you draw this graph, to answer that question, what happened? Okay, that's descriptive analytics. So for example, monitor historical yield performance, summarizing rainfall by region, report fertilizer or pesticide usage. That's what happened. You have a field, you know, every year you're going to apply this kilogram of fertilizer, you're going to apply this milliliter of pesticides and so forth. That answers the question, what happened? That's descriptive analytics. Okay. This is an example of the data that we have, and eventually you're going to download this. So this data set is about crop recommendation, and this data set has 8 crops: chicken, pea, coffee, up to wheat. And then you have nitrogen application, phosphorus, potassium, and then also those are fertilizer. You have average temperature, humidity, pH, and so forth. And then also you have yield category in kilogram per hectare. Then you have yield category. So you can use these data to help you answer some of the question. So I'm going to use these data sets to try to guide us answer some of the questions in analytics. So we have this, okay. So we're going to use these data sets to help us. Okay, so descriptive analytics, what happened? So from the crop recommendation data, you can see that if you look at average fertilizer applied NPK, which is nitrogen, phosphorus, potassium, let's take for each crop here. So for chickpea is 43.1 kilogram, coffee 85, cotton 81.9, and so forth. So this is what happened, the nitrogen level for each crop. What about phosphorus? You can see all of them are different, and all this will affect the yield. But this is descriptive analytics, and this is potassium, the K. You can see they all have different values, and then this is the crop yield. So this asks you the question, what happened? So you look at the data, you summarize this now, it gives us a snapshot what happened. Okay? Okay. The first few slides that I talked about was what happened. And in data science, we don't stop at what happened. Then the next one is diagnostic analytic. Why did it happen? Okay. So here, from our data sets here, you have these crops, have different fertilizer application, have temperature, humidity, and so forth. And then you have the yield, and then the yield category. This was the raw data. You go to risk analytics, you start summarizing them. So these are the applications for each crop for nitrogen, phosphorus, and potassium, and these are the yield in kilogram per hectare. So this is what happened. So now you got to ask the question, why did it happen? And that's what our diagnostic analytics. Why did it happen? Why did we get this? Why did we apply this fertilizer at this rate for this crop? Why did we get this yield? So diagnostic analytics seeks to uncover reason behind certain trend or anomalies. Let's take locusts. Our descriptive analytics is maybe every 4 years, you have locusts affecting a certain area. That's our descriptive analytics because that's the trend. When it comes to diagnostic analytics now, why do we have this locus every 4 years? That's diagnostic analytics now, okay? For example, here, if maize yield dropped in a particular year, so you have the average, you have this field maybe 10 acres of, so on your average, it's a 10 kilogram per year. So you get that, that's your description analytics. Every year you may get a certain kilogram of maize per hectare. Then 1 year it dropped. You're going to get less in kilogram per hectare. That will be a descriptive analytics. And then the diagnosis will be, why did we drop? Why did the yield drop in that particular year? So the diagnosis analytics can help you determine whether the cause was due to, for example, this rate for the maize here, inadequate rainfall, pest infestation, or nutrient deficiency. So our descriptive analytics was about trend. Every year we're getting a certain kilogram of maize per year. And then this year, the yield dropped. So that was our descriptive analytics. What happened? And then now we have to go to diagnostic analytics. Why did it happen? So now you go back and start, okay, was it because of rainfall? Because of pest infestation? Because of soil and other things. So that's where diagnostic analytics comes in. So in data science, start from descriptive analytics, then you come to diagnostics analytics to find why did it happen? Okay. Okay, so I already explained this in the previous slide. It helps to identify causes of yield drops, detect relationship between soil and crop, or report fertilizer pesticide application. So that's like diagnosing what's going on here. So this is an example. Correlation is part of diagnostic analytics. So if you look at this data set here, we have crop, different type of crops here. We have all these fertilizers, different type. We have temperature, humidity, and so forth. So when we did averages here, it told us that's what happened. But now, when you go to diagnostic analytics, we have to go beyond these numbers here. So one thing that we can do, and Peace is going to talk about, I think tomorrow, cover about diagnostic analytics, but this is just an example. So we have this correlation plot here. The bigger the bubble, the bigger the correlation. And the blue indicates positive correlation, and the red indicate negative correlation. So of course, the diagonal is a variable correlated to itself. So nitrogen by nitrogen is 1, which is dark blue. So if you look at, let's take this here. You can see that take a nitrogen is correlated with phosphorus but the magnitude is a little bit smaller, but it's bigger for potassium and so forth. And nitrogen is negative correlated with pH. So now you can start seeing the correlation here. So that's mean, why did it happen? You can see also yield, the correlation with pH is very, very low. You can see that. So that helps. So there are different tools that you use for diagnostics analytics, and Peace is going to cover some of them tomorrow. Okay? Okay. So the next is predictive analytics. So predictive analytics, most people think data science is just predictive analytics, but data science cover all those 4. So predictive analytics, what might happen? So this uses statistical models and machine learning to forecast the outcomes, okay? So in agriculture, this might include yield, predicting yield, or forecasting disease outbreak, and so forth. But you have to have information starting from descriptive, diagnostic, in order to do this. So it relies on historical data and real-time to generate insights. So in data science, predictive analytics is used a lot. And most people, when they talk about data science, they only think about predictive analytics. No, in data science, we have those 4 analytics, and you have to go step by step, okay? So example, focus crop production, predict pest and disease spread, and anticipate future input requirement. Okay, let's go back to locusts. So let's start with our descriptive analytics. So every 4 years, 4 or 5 years, let's put that, every 4 or 5 years, we have locusts coming. That's our descriptive analytics. In diagnostic, we can know why they're coming every 4 to 5 years. Maybe where they do the breeding, maybe we don't have food. So maybe there's a cycle. Maybe also it depends on the rain. And then we also have other variables. So using those variables, you can now use predictive analytics to help you determine maybe which month, because they can come every 4 years, but the month might fluctuate. So that might help you, historical data might help you to determine which month these guys are going to come. Okay? Another thing that predictive analytics can do is anticipate future input requirement. You can get historical data, and then you can predict based on the historical data, the fertilizer or what type of fertilizer and what amount is needed to apply. So this is again our previous data. So when we did descriptive analytics, we just took averages of each to find that for each crop, we needed this amount of nitrogen, we needed this amount of phosphorus, and we got this amount of yield. And then when we went to diagnostic analytics, we saw the correlation. Nitrogen was correlated most with phosphorus and potassium, but the magnitude was varied. And then we saw that the pH was negatively correlated with the yield. So that was diagnostic analytics. But now, we can predict also using this historical data. We can use predictive analytics to predict either yield in kilogram per hectare, or we can also predict yield in category. So we can use this information. So this can be our dependent variables, so that in the future, when we have this information, we can predict if a crop is going to be high yielding or low yielding, okay? So we're going to talk about modeling on Thursday, but just bear with me here. So this is we're going to do the modeling. So what we're going to use this historical data, we're going to model this. So then when in the future you get your new data sets or your test data sets, you're going to predict the category. Because when we are using the machine learning, this is going to be our independent variable, it's going to be a dependent variable. So we're trying to predict this. And then our model will have this. So in the future, we can now predict that if you're given the nitrogen, phosphorus, potassium, and information about temperature and so forth, you'll be able to predict if a certain crop is going to be high yielding or low yielding, okay? So, but when you do the prediction, which we're going to discuss that on Thursday, machine learning or statistics not 100% accurate. So you're going to, some of them, there's going to be some misprediction. For example, here, assume this was our test. So we predicted our reference category. This one was high, and then our prediction was high. But this was high, but predicted as low. And this was low as predicted as high, and so forth. So in data science and statistics, you have to have at least a matrix that will help you when you have these methods, so that to make it so that when you use in the future, it's reliable. And we're going to cover that I think on either Wednesday or Thursday. So that's what predictive analytics does, okay? Okay, so I've talked about descriptive analytics, what happened, diagnostics, why did it happen, and predictive, what might happen. But you cannot stop with the three, because the ultimate goal is to make sure that when I mentioned the advantages of analytic or data science, you need to minimize your resources, efficiency, and the rest. So you cannot only stop on the three. You have to go to prescriptive analytics. So this one now give you recommendation. So after that, ask you what action should we take. For example, it can give you what fertilizer applications, what are recommended rates. And then when you're working with irrigation, it will give you the schedules of, okay, what particular time are you supposed to irrigate? Or when you're dealing with crop rotation, also what type of crop should you rotate? So that one is what prescriptive analytic does. So it gives you now the recommendation of what you have done from descriptive analytics, diagnostic, predictive, and prescriptive will now guide you. Okay. So what are the examples? Focus crop production. You can predict pest and disease spread and anti-pest feature inputs, as I already mentioned. Okay, so let's go back to our data. So after we did the modeling, now we can use prescriptive analytics to help us plan on a budget so that we can use the resources to realize the amount of yield that we need. For example, if after going through those three analytics I talked about, the recommendation was you're supposed to apply 120 kilograms of nitrogen, 60 kilograms of phosphorus, and 80 kilograms of potassium. So we want to buy as cheap as possible. So the first thing we need to do is list the prices from different sources. And then after that, we use price optimization so that we can model to get your best price for the fertilizer. So analytics has helped us. First of all, we went through all this analytics, but it helped us to come with the right amount of the fertilizer that we need to get the optimum yield. But we cannot stop there because we need to save money to be efficient. So we have to get to get the best price as possible. So what we're going to do, we're going to go and get a list of all the prices from different sources. And we're going to use price optimization so that we can model to get the best price of fertilizer. Okay? So just briefly, those are the 4 types of analytics. And that's the core data science. Descriptive analytics, what happened? Diagnostic, why did it happen? Predictive, what might happen in the future, and the prescriptive, what happen in the future to help. Okay? So, but now we have another analytic that has come. What's called generative AI. People use ChatGPT or DeepSeek. This is what is generative AI. So this is another dimension now. What should be done? So generative AI, some people call GenAI, is a type of new artificial intelligence that can create new contents such as text, images, audio, code, even simulation. So what's the difference between our traditional, what I just discussed with the Gen AI? For the Gen AI, it has gone one step further. For example, you can train Gen AI with different images, and then the output can be trained now to give another image. You can train Gen AI with different types of music, and then from that music, the output can produce another type of music. Okay, so it is really changing the world. Really, it's changing the world. So people become creative. People even now making movies in that basement. So basically, it complements analytics by expanding the possibility for training models and exploring future scenarios, okay? So it's still the same, it learns from historical data, but the difference is it trains on large data sets, That's why we have, these days we have these places where people do this training of this Gen AI, and they're called data centers and take a lot of energy. And also the type of computers that we have now is different for training this. So it generates unique text, images, sounds, model from the learned patterns. It's powered by an advanced model, often uses deep learning methods such as transformer or GPT, generative pre-trained transformer, or Llama. So when you're using ChatGPT, basically you're using GPT, but it's just a chat bot. But ChatGPT can do a lot. And almost everybody uses it once or twice a week. So this basically is Gen AI, but it's just a chatbot, but it's very, very powerful. Okay? So how can you use this in agriculture? One, we can use for crop disease diagnostic. You can generate disease crop images from AI training and give farmers AI-based treatment and advice. So it's changing the way people are doing things now in agriculture, especially now people use drones, rovers, because of Gen AI. It's also helping in climate and yield stimulation, because creating synthetic data, different scenarios. Also, it helps with content creation, for example, produce a personalized crop guide, farmer training materials in local languages. The good thing with Gen AI, it's very easy for it to translate different languages. So people are now using it in agriculture to translate what used to be a complicated language to local language. So smart farm planning, you develop optimized crop rotation, fertilizer, and so forth in real time. And also synthetic data generation. We used to have problem with generating data, especially, but now with Gen AI, it's very easy to generate data that we use not to have. So it's helping a lot in agriculture. So what's the application in institution? Let's start with educational research. It assists in literature reviews, content creation, and training. It helps a lot, especially sometimes when you're doing a literature review, use something that used to take you like 3 to 4 weeks. Gen AI can do it in just an hour or so. It's now helping in supporting clinical decision-making and patient education. So 6 months ago, they did some research, some experiment in the US. They compared the performance of doctors and Gen AI. Gen AI outperformed doctors, really, in most of the tasks that were given to them. So that's a little bit scary, but Gen AI outperformed doctors. Public policy, they're helping drafting public policy, simulate outcomes, and analyze large data sets. Business operation, automated reporting, customer service, content generation. For example, if you are on TikTok and you start thinking around, before you know it, TikTok is sending you something that something that you were not expecting. TikTok has the best algorithm of Gen AI. It will give you based on your search. It has gone beyond, really. That's why I think people are fighting for it. It has the best algorithm. So each time you go to TikTok, don't be surprised that what you're watching what's being sent to you is not the same what's being sent to your friend. It's what GenAI is doing. Okay? So for industry, prototypes, media and design, so GenAI, as I mentioned before, people can now make videos or even movies in their basement. So it is going to change the world, really. It's going to change the world. And we have to embrace it. We have to embrace it. It has come to stay. But everything has disadvantage. So we have to make sure ethical consideration of GenAI. Transparency, explainability is crucial. We have to clearly communicate AI decision-making process. Fairness and biases, because when you use data sets that is not representative, it's going to discriminate other groups. So we have to make sure that our data sets is representative. Privacy and data protection, we have to safeguard personal and sensitive information. Accountability, how do you find responsibility for AI-generated outputs? As I mentioned, AI sometimes can generate images that you might think is a human being, but it's not. Responsible use, prevent misuse, misinformation, plagiarism, and harmful content. These days, with Gen AI, somebody can send you something that you might think is real, but it's not. So we have to make sure ethically what we are doing with Gen AI, especially in policy aspects of it. It's a good, I mean, it's something that it changed the world, but to make sure that what's being done is the right thing. Yeah. Okay, that was analytics. But now I'm going to move to analytic life cycle. Okay, so we talked about retrieval analytics, what happened, diagnostic analytics, predictive analytics, prescriptive analytics, and now we have GenAI. Okay? Okay, so how do you do your data science project? So we have a group that came up with this kind of guidelines of doing data science project. So it's called cross-industry standard process data mining. So it has 6 phases. The first phase of any data science project is business research or understanding phase. And then the second one is data understanding phase. You have to understand the data. And then you go to data preparation phase. And then after that, you do your modeling. Then you evaluate your models, and then you deploy. So the next 5 days, we're going to go through this. And our last day on Friday, we're going to deploy some of the models. We're going to use Shiny to deploy our models. Okay? So this is analytic life cycle. So if you're going to do data science project, this is how, and sometimes you have to go back. For example, you can start with business understanding. Of course, you meet with your domain expert if you are doing consulting, or if you're, then you, after that, you can either collect data if you don't have, or you can use the data. When we were teaching introduction to data science, bioinformatics, and data management, we had a similar situation in Kenya. We had a business person who wanted to go into tourism. So we went and sat. That was business understanding. So what he told us was, I want to go to Kenya and start business tourism, but I don't have the data. So the second phase was data understanding, but we didn't know what type of data we need until we went to a website and started mining the data. But when we got the data, we had to go back to him. You see this arrow? You go back and sit again and better understand. Okay, so we went to the website, we mined the data and said, okay, this is what we have. Is this what you're looking for? And said, okay, that's what I'm looking for. Then we went through the data preparation and so forth. Okay, so the next few minutes, I'm going to go through each stage one by one. Okay. Okay, business research understanding phase. The first thing you have to do by saying clearly what you want to achieve and what you need. Explain in terms of your work or department, if you have department. The second, you turn those goals into data problem. Figure out what information you need to collect or analyze to reach your goal. And make a first plan. You outline your steps. Do you have the data or you don't? And you study that. So that is business and research understanding phase. You don't have the data or you have it, but sometimes you have the data, but it's not going to answer your problem. Okay? So this is an example. I would still go back to agriculture. So the objective is support decisions that increase yield and reduce cost. So for the question, the description analysis, what happened to yield, rainfall, inputs over time in a certain region? That's your descriptive analytic question. Your diagnosis, why do yields differ? Soil, weather, pest, and input. And your predictive, can we predict the crop level from conditions that given above? And your prescriptive, what nutrient additions meet targets at a minimum cost? So this is your business understanding. Other areas would be different. So I'm just putting this because agriculture part of it. So this is your business understanding. What happened? Why? Can you predict? And so forth. Okay, the second phase is data understanding phase. You start by gathering your data. For us, we went and mined the data, the website. So you bring together all the information. The best thing for a data scientist, if the organization has data, that will be perfect. But most of the time, they don't have, or they have, but you're missing some data. So you look through the data to exploit it. So that's what Peace will be doing tomorrow, data exploration. You get to know what's in the data and spot any usual trend or surprises. You check if the data is good quality, make sure it's accurate, complete, and reliable. If you want to pick out the most interesting parts, because you have, or sometimes you're not going to use all the variables. You have to focus on pieces that might reveal useful action and decisions. It's your data understanding phase. Okay, this is one of the data that we're going to use. So this data is a huge data. It has information on year, month, also the geospatial location, NDV, and so forth. So if you have a data like this, you have all these variables. Some of them are missing. So you have to understand a data like this. Do you need all the information? We have information on yield. You have information on malaria. We have information on other things. So if you're going to work with only crop, we don't need other information from maybe other diseases. So you have to determine what you're going to work with. But if you're going to do One Health, you're going to work with crops, you're going to work with animals, you're going to work with. So that comes from your first question, research questions. Because you're going to get all this data, but do you need all the information? So I was showing this, that we have this data sets that has information on population density for human, you have population to livestock population density, you have distance to water in kilometers, you have crop yield, you have malaria, and so forth. So if you get data, you don't have to use everything in the data. That's why you have to make sure that you know what your research question is. Okay? So this is an example of data understanding phase. So we had the questions that I presented in the beginning. So now I can go in now, since I'm only interested in maybe something to do with crops. I'm not going to use all. So the ones that I put in red, those are the ones that I'll be interested in using them. The rest, I will not be able to use them, okay? That's the data understanding phase. Okay, so after understanding your data, you go to data preparation phase. So basically, data is messy. You're going to start with your messy raw data. So this is basically unprocessed information you collected. So you choose the records and details you actually need. Only keep what's useful for your analysis. One is going, if your computer is small, you put everything there, it's going to be hard on your computer. Okay, change or adjust some details if needed. You can combine columns, you can change format, you can and do other things. Clean your data to remove errors, fixing missing values, and so forth, okay? Okay, so after doing all this, now you come to the modeling phase, which we also do I think on Thursday. So when you go modeling, many students also ask me, what's the best method? When you go modeling, you don't know which method is going to be the best method, really, until you go through the modeling process. So choose the approach that fits your problem, adjust the setting to get the best results. So sometimes you fine-tune those. Try more than one method if needed, at least minimum 3, okay? Go back and fix the data if required. If a method needs data in certain format, adjust and try again. So this is basically your predictive analytics part. And then you evaluate your model. Check how good the model is. See if it works well and gives reliable results. Because sometimes when you're doing modeling, it can give you very good accuracy, sometimes 90-something, but you have to take it to the real world, it won't work. So you need to make sure that it's doing what your objectives are, okay? Make sure it meets your original goals. Confirm it's the answer problem you set out to solve, okay? Something happened here. Okay, the last part is deployment phase. Building model is not the end. You have to deploy it. People have to use it. So you need to put into use, for example, you have to create a report with the results. For us, we're going to develop a Shiny app. You can run the same kind of analysis with another team or department. Can you make an interactive app like Ara Shiny dashboard so people can explore and use the model? In business, the customer might take the model and use it themselves to make sure it's working. So those are the 6 phases of doing data science, really. And it's called analytic life cycle. Okay? So let's take a 5 minutes break. Then we'll come and start working on Ara. In the meantime, continue installing your Ara, because when we come back, we're going to work with Ara, okay? Let's take a 5 minutes break. Okay, we're gonna go ahead and continue with our webinar. Okay, so I assume most of you have downloaded your RStudio. So we're going to go through that. And then after that, we'll go and create our project. So what's RStudio? So RStudio is basically an integrated development environment called IDE for working with R. Basically, sometimes I call it Windows graphical user interface for R. So it has 4 editors that includes console, which I'll show you later. Also, it has where you do the scripting. It has tool for plotting, history, debugging, and workspace. And it has 2 versions. One is open source, that I think most of us use that. And then it has commercial that most industry use. So another thing with RStudio is platform independent. What does that mean? That means you can run it on Windows, you can run it on Mac, and you can run it on Linux. We have some other software that is not platform independent. Sometimes they're only made for Windows, sometimes they're only made for Mac, and sometimes they're only made for Linux. But RStudio is platform independent. That's why we are able to download it, okay? So if you want more information about RStudio, you can get it from this website, since we're going to share the notes. So this is RStudio. When you open it, it has basically 4 windows, okay? The first one is script editor. So script editor is where you can start your script. You can do the programming by itself. So when you want to start maybe from scratch and start writing your other script, you use a script editor, okay? And then you have R console. So R console is whatever you do in the script editor, or when you run, the results will appear in R console. And then R console also, you can type your work in R console, but you have to use your enter
Nice,
key.
it's written what there?
But when you are using your script editor, you have to just click on it, okay? And then workspace. Workspace will show you the files you have uploaded, and then other information. And then also
Today
you have history. So whatever you're doing
for those ones who
in
inherited
the
the job,
script, it will come in your history.
more money that been started the.
And then you have the view, which can, and then you have the help part. You have the plots, the files to manage, and the packages. So on the lower side, what we will not use all. We'll just use the file and also the plot and the packages, okay? So for those who have already installed your RStudio, can you open? Can you open and let's see if you have these 4 windows. So open and then put in the chat yes if you can see these 4 windows, those who have installed. Open your RStudio and see if you have these 4 windows. You have your script editor on the left, your console or script editor on the upper left, your console on the lower left, your workspace and history on the upper right, and view, help, plot, files, manage, and packages on the lower left. Let me know if you see these 4. Let's type yes. Somebody said they can only see 3. We'll work on that. As long as you have, we'll work on that to make it 4. Okay, so what I'm going to do, I'm going to go in Ara Studio here. You see my screen? See my Ara Studio? You see my Ara Studio
Hi,
screen?
Stephen.
Yes.
Stephen, we cannot see your screen. Julius, please stop sharing your screen so we can see Stephen's screen.
Okay, can you see my screen now?
Yes.
Okay, those who have only 3 windows, you see my cursor here? You see, you should click on this, you should click on show all panes, you should get 4. You see my cursor here? You click on works and you just click show all panes, then you'll get 4. So you should see something like this. So on this upper left, we have your script editor. In the lower left, we are going only to, we have this, but we are only interested in the console. On the upper right, we have environment and history. We click this, and others, but we are only interested in these two, basically this one here. And in the lower right, we have file. These are the ones we're interested in: file, plot, and packages. But you also have help and so forth, but we're only interested in this. Okay, so this is how your Ara Studio should appear, because soon we're going to do something with this. Okay. So please do see my slide.
Yes.
Okay, good. Okay, so before we do anything, we like to talk about how we work with Ara Studio. So basically, you can work in either the script editor or with the console. So in a console, if you look at this, if you look at the console and you have this greater than sign, it means that you can type something. So if you want that Ara should not read what you're typing, use this hash sign. So this is just the comment, okay? So this is just a comment. And then in Ara, whatever you do is stored in an object. So to put that in an object, you use this what's called as assigning operator or equal signs. But we always discourage equal signs because when you're writing your Ara program, sometimes you use the equal sign, okay? So for example, I would like you to go back to your Ara Studio. We're going to do together. And then this test is our object, okay? And then we're going to put these two, basically it's like our store. We're going to put these two in this. It's the same when you type test and equals to, you're going to put that in that, okay? So let's go back in your Ara Studio, open, okay? I'm going to go back to Ara Studio, okay? So let's start with console first. Remember, you see this sign here? This greater than sign. When you're in console, it tells you it's ready to do something, okay? So we're going to deal with console first. We're not going to deal with script editor. So you type this test, okay? Less than with a minus and put 2 and enter. Can you do that? What I did, Type test. So this test is your object. And this 2 is going to be in this test here. It's going to be stored there. So if you want to see what is in 2, you just type test. And the 2 will come. Okay? We can do the same. You can type test 2. So we're going to put this 2 into test. Okay? If you type test again, you should get 2. But we always discourage you using this equal sign here because in R, this one, sometimes you use it when you're writing your program. So we always encourage you to use this, assigning this one here. Okay? Are you with me? Okay. So this is our console, and I would like to see something here. So if you click on history, whatever we did in console, it is in history here. You saw that? So whatever you type in console is going to be in history. Whatever you do in the script is going to be in history. That's what it's all about. Okay? You can use history, you can use the information history to create your script, but I just want to show you that. Okay? So this is how you store anything you are doing in R in a holder called object. And our object here is called test. Okay? So let's go back to our slides here. Okay? So you can also combine. Here we only put 2. You can also combine information by using this C. It's called concatenate. So you can type test 1, you put this C, and then after that type test 1 and see what you get. Okay? You do that exactly like here. Type test 1 and this assignment operator. Don't use, from now on, we're not going to use equal. Type test 1 in your console still. And this assignment operator, and you just small c, open bracket, 1, 2, up to 5. When you're done, then type test 1 at the bottom and enter and see what you get. So if you're done, just put yes in the chat. Somebody say, my console has was that, and I don't see the greater sign. The greater sign is you have to sign to do it by yourself. The greater sign should be on your keyboard. Okay, let me go back. The greater sign should be there. Let me go back. Let me go back to RStudio. Let me create a console here. You see this greater sign here? This is the greater sign. You see that? The person who wrote on chat, this is the greater sign here. And they should be blinking, telling it is ready. This is the greater sign. Okay? Okay. So I think we're okay. Okay, so let's go back to our slides here. Okay, so we saw that to assign any work, you have to use the assignment. But how do you name your object? Where you're going to store your thing? So R has its own rules. You cannot use strange symbols to name your objects, okay? So I would like you to do this. I would like you already typed this one here. I would like you to type this one, test with exclamation mark, and do the same thing and see what happens. Go back to your RStudio, still in console. Type test with exclamation mark and do the assignment. The same thing you did with only test. And enter, see what happens. you should be able to get an error. See, we are still using console. Okay, you have to, because that rules that what? You cannot, the names cannot contain any strange symbols. So when you are naming, you should not use all those exclamation mark, plus, and minus. So let's go to the next one. The name can contain a dot. The name can contain underscore. So I want you to type this one here, and then also this one here, and enter and see what you get. So when you're done, just put a yes. Okay, somebody's lost. Okay, let's go back. Okay, let's go back here. I'm going to go to ARA Studio, okay? Somebody said they're lost. Okay. First of all, I would like you to open your ARA Studio and make sure you have these 4 windows. If you have less than 4, you see my cursor? Click on this workspace and click on show all panes. You should get all those. You should get all the four windows. Do that before we do anything else. And right now we're only using console, by the way. And with console, when you see this greater than sign and this blinking means you're ready to go. Okay? So the first thing we did was we put our object, I'm not going to use the equal signs. We put 2 in our object and we entered. And then when we type test, we got our 2 back. What is inside here is given here. Okay? And then the second thing that we did, we now combine not only one number. To do that, we use this small C called concatenation, 1 comma, 2 comma, 3 comma, 4 comma, and 5. And then we type enter on here. And then when you type test, you should have 1, 2, 3, 4, 5. Okay? And then now we came to naming of our object, because whatever we are putting in is called object. The first thing the rule that we know in ARA, you cannot use symbol to name your objects. The symbols are like the plus, the minus, the exclamation mark. So I'm going to use symbol. I'm going to use exclamation mark here in naming, and I'm trying to put 2 there. I get an error. So why do we have this error? Because we have violated the rule. The rules say that you cannot use any symbols. So now if I type this one here, there's nothing because we were not able to put 2 in this. Okay? Another rule in ARA is that you can use a dot and underscore to name your object. So I can use a dot 1 to name my object. So I'm going to put red here. I'm going to put blue. I've introduced something I'm going to explain to you. So look at this. You see this? So basically, we are writing program. We are scripting now in ARA, but we're doing in console. So if you look at this, I put 1, 2, 3, 4, 5 without what? Without quotes. But when you are using characters, you have to put them in quotes. Okay? So we said we can use a dot in naming our objects. So if you enter .1, red and blue. Another rule is we can use also underscore, okay? So okay. Are you with me now? Somebody was lost. Another rule that we have in R Studio and R is you cannot name your object starting with a number. Okay? So let's start. I'm going to do the same here. I'm going to use 2. Let's give another name here. You see, I got an error because I violated the rule. You cannot name your object starting with a number. Okay? But my object the number can be at the end, okay? Okay? So you cannot start naming your object starting with a number. Another rule is R is case sensitive. So if I name my object starting with a capital letter, and when I go to call it with a small letter, it's going to give an error. So if your object starts with a capital letter, the result should be in a capital letter. So let's do this again here. So we're starting with G. Okay, I'm just going to put okay. So let's get our goal 2 here. Okay. So you get what? Red, blue, and green. But now if you go back and now type gold in a small letter, gold 2 in a small letter, and we enter, you get an error because our object here was in capital letter, but here it's small letter. So we had this problem 2 weeks ago when we were working with data management. Some people were trying to, instead of using the right naming, sometimes they could use uppercase, sometimes they could use lowercase, and it wasn't working. Okay, so any question with naming? Okay, so I think basically I've covered everything up to, please do you see my slides? Please do you
Yes.
see okay. So this is what I've been covering, okay? Okay, so we have covered the object. Everything in R is stored in object. And we've covered how to name objects. That you cannot use symbols. It cannot start with a number. You can use dots. You can use underscore, and R is case sensitive. So I'm going to talk about packages. So in R, sometimes you need packages. Sometimes we call them library for you to do your function. So in order to install packages in ARA, there is you have to use this install.package in bracket, and then you put the name of your package in the what? In quotes, in double quotes. So before you use any package in ARA, some come pre-installed, but before you use any package in ARA, you have to install it. And then after you install that package, you have to load it before you use it. So how do you load it? You load it using this function called library. So here we're installing a package called dplyr. And then after, when you want to use dplyr, that will be using tomorrow when Pete is teaching, you have to call the library. Okay? You can type, but I'll also show you a way that you can just click and go. That either way, you can install by typing install.package, install.packages, and you put your package in double quote. And when it is installed, before you use the package, you have to call it, use a library. But when you're installing your package, you have to be connected to the internet because these packages are stored somewhere in the clouds. It depends how close you are. Some are in South Africa, some in Europe, some in, I think, Kenya or somewhere. You have to be connected to the internet. If you're not connected, you're not going to install those packages. Okay? Another way you can install packages is through your ARA Studio. So on the lower left corner, first you click on install, and then you click on packages, and then number 3 you type the name of the package you would like to install and click install. Okay, so this is the easiest, by the way. You click on install, you go to your packages, and you type. So I'm going to install one package. We're going to go back to R, and we're going to install three or four packages together, okay? So this is what we're going to do. We're going to install 4 packages together. And we're going to use, now we're going to use this, okay? So let's go back to R. Open your ARA Studio. I'll work with you guys together, okay? Open your ARA Studio. Clear console here. So I also want to show you something. You can also clear a console. You go to edit. You see my cursor where it is. You go to edit, and you clear console. So you see my console still has what we've been working on, okay? I go to edit, and I clear console, and it's gone. I can also clear my S3. You see this broom here? If you click on it, this will go. Again, to clear your console, you go to edit, and you clear your console. Clear your history, you use this broom here. Okay? Okay, so we're going to install packages. Okay? Click on packages, okay? Click on install. And then we're going to install, the first one is, let's see, the first one is, we're going to install dplyr. So we're going to type dplyr in this box here. See this box? If you type it, it will come. And then you install. Click install. Okay, let's go back. Packages, install, and we tap dp, this one here, and click install. And if you're done, put, me already have it, that's why I'm not installing. If you're done, put yes in the chat. Let's just install it. I reinstalled mine. The second one we're going to again to install, I think should be, let me see here, Read Excel. Okay. Read Excel, this one here. Okay. We're going to install. Click on that. Are you with me? The third one is what? Write Excel.
Mr. Pio, your screen is not being shown.
Pardon?
Your screen is not being projected.
It's not being shown?
No.
Okay, let me try again. Sorry about that. Give me a minute here.
I think maybe he has a problem. The screen is okay.
You see my screen? Let me make sure. Okay, I'm going to share my screen again, okay?
Actually, your screen was showing maybe his was having problem, but after he said, and then you stopped sharing.
Okay, so do you see my screen now?
Yes.
Yes, very clear.
Okay, I'm going-
Yes,
It's on
maybe
now.
the only concern is that maybe if you are recording, because I believe you stopped before when we had a break. Thank you.
Oh, the recording is I think the recording is it not on?
It's on, it's on.
Oh, thank you. So how many have we installed yet? We have installed up to Write Aaron also. So the last one I think is Haven. Okay. So again, you start with the package, install Haven. This one. So we should have 4 packages installed. Okay, I want to share with you something. You see my history? I was installing it from here, but it was writing here. So I could have written this one by myself. So everything I was doing was being done in history here. Okay? You click on history. You see something like this? You should, I mean, your history should be having more. I don't know whether you guys have cleaned it or not. But this year, everything I was doing, we were doing here was being recorded in the history. So how do we use history? I want to show you something, but okay, so we can, I want you to highlight these installed packages. I want to highlight those. You see this to source? If you click on that, you'll take it to script. Okay, let me get this out here. So whatever we were doing, we're installing our packages. Whatever we're installing our packages, it came here. I don't know why I don't know why I don't have Haven. Let me see here. Yeah, I didn't install it. So whatever we did here, we have in a history. So this, I would like you to highlight everything here. You see to source? Click to source. It's going to take to our script here. So I would like you to go to file on your script side. Go to file and save as.
ya iko na nguvu sana like the lady
Okay, let's,
unaona mrembo mzaa
we haven't,
kuna nguvu.
don't save this. I just wanted you to, I wanted you to know that anything in the history you can put it to be your script, okay? So have we all installed our packages? Just type yes. Then we can continue. Because we need those packages, by the way. Okay, good. Okay, let's go back now to our slides here. Okay, so now we're going to create what's called a project. But before we do that, I'm going to talk briefly what a project is. So in R, the best thing we can do is to organize our work, because if you're working with very many projects and people, it would be better to organize your work. And then when you organize that work, you have a folder called a project. In that project, you can store your code, you can store your data sets. So every time you open your R Studio, you go to the project, and that's what we're going to do. We're going to create our project together. But before we do that, I'm going to take you through how to create the project from the slides, and then I will guide you in R Studio, okay? So how do we do it? So don't do it right. Don't do it right now, because we're going to do it together. So you have your 4 windows. You go to File, you click on New Project, okay? After clicking on your new project, it will bring you to Create Project. And under Create Project, you'll have three folders. One is going to be New Project, New Directory, Existing Directory, and Version Control. You'll select the first one, New Project. New Directory, okay? We have New Directory, Existing Directory, and Version Control. You select the New Directory, okay? After that, you click New Project, okay? On Friday, we'll select Shiny Application, but this one we're going to create New Project, okay? And then you browse. We want to create, all of us are going to create a project on our desktop. So you browse and select your desktop, okay? You select your desktop and click Open, okay? We're going to do that together. And then now you have your desktop, okay? And then you're going to write data_science in all small letters. Data_science. After that, and then you click Create Project. And you should have a folder like this on your desktop. This is my desktop. You have a folder like this on a desktop. And then when you click on that folder, you have a data_science.r project. After finishing that, and then we're going to go and download files from the Google Drive, the file we're going to work with. So I'm going to repeat again, and then we're going to go and do it together. So first of all, projects will help us organize our workflow. And always advisable to have a project for every project you're working on. So it stores your R script, it stores your data, it makes life so easy, okay? So how do we do it? We're going to go to File, click on New Project. That will bring us to 3 different areas, and we're going to go, there's New Directory, existing directory and version control. We're going to go to new directory. We're going to click on that. And we're going to click on new project. Okay. And we want to create a project on the desktop. So we're going to click on the browse. We're going to select our desktop. Okay. And you'll see this folder here, desktop. And you click open. Okay. And now you write data_science. You click create project. And you'll see on your desktop a folder called data_science. And when you open that, you should have a file that has been created. It's called data_science.r project. When we're done with that, then we're going to go to Google. This will give you a link. And I'll tell you data sets to download. So let's do it. I'm going to go back to RStudio. So I'm going to clean my console, edit, clear console. This is clean. I'm not going to save this. I'm just going to delete this. I'm going to clear it. I want everything to be clean. Okay. Okay, so let's start. Put your cursor on the left upper. Click on File, and click on New. Click on New Project. File, New Project. Okay? Click on that. We're going to have these three. We're going to create a new directory. Click on that. Going to give you new project. Mine, I'm already on desktop, but you have to browse so you can find where your desktop is. Because always when you open R and RStudio without creating a project, you are going to be on your, in your document. I'm going to go back again and start. I have 4 windows. I'm going to go to File, New Project. Don't save workspace. I'm not going to save that. And I have this, the first one, new directory. I click on New Project. I'm going to go to Browse. I'm going to select my desktop, and I'm going to open. And I'm going to type data_science. And I'm going to create, I already have mine, so I'm not going to create. Okay, I'm going to repeat again. File, New Project, New Directory, New Project, Browse, Desktop, Open, Data_science. If I click on Create, I should have data_science on my desktop. So if you have done this and you have succeeded, just put yes. Okay, somebody said they have 3 windows. So you have 3 windows. If you have 3 windows, because something happens and the one window disappear. So you see my cursor here with these 4 kind of like 4 small triangles there. I mean, small rectangles there. If you click on that, it will bring all this. You just click the first one, show all panes. You have 4 windows back. Let me check to make sure people are. Okay, so I'm going to give the rest at least another 5 minutes, then we're going to go and download data from Google Drive. Okay? So anybody has any problem creating data science folder, a project? or somebody has only, even if you have only one window, do the same thing. If you have only two windows, do the same thing. If you have one window, do the same thing I've shown. If you have a one window, go to this place and do show or pane. The same with two windows and three windows, okay? The same process. Come here, show or pane. Okay? So I'm going to give another 2 minutes, and then we're going to go and download data sets from Google Drive. Okay, so if you have data science on your Windows, Peace is going to give you a link to Google Drive, and I would like you to get these data sets and put in your data_science folder. So I'm going to give you some time to do that. So you have crop recommendation.csv. You have Kenya Agri Disease Special.csv, .xls, .dta, and so forth. And then you have this one here. So this is the link, but Peace is going to give you that link. So I'm going to give you another few minutes to do that and put in your folder. So are we okay with creating the folder? Anybody has any problem?
Yeah, well, I'm not seeing the link in the chat. Okay, she has just shared it here. Thanks.
Then I make a copy paste. I have already downloaded it.
Okay, I'm giving another 2 minutes, then we continue. How many people are still downloading? Can you please share the link? Someone's asking for the link. Let's give some minutes to those who haven't downloaded yet. Somebody asked, where's the file to install AraShiny? We're going to install AraShiny on either Thursday or Friday. We'll send you the file for installing later, okay? We didn't want to install all the 3 at the same time. So we're going to, that will be done either Thursday or Friday, okay? So Shiny, we are not going to work on Shiny until on Friday, okay? Okay. So let me continue here. Okay. So now we have, you guys have installed, downloaded the data. Now we need to import the data. So how do we do that? If you go on your upper right corner and you click on environment, you can see different methods of installing, of uploading data. You can use text base, that is text file. You can use text read R, that is comma separated value. You can import Excel. You can import SPSS, SAS, and Stata, and so forth. So we're going to go through this slide first, then we're going to go. I'm going to go and show you in RStudio, and then you'll practice. Okay. So when you try to this one, I'm importing comma separated value. When you click on that, you'll see something like this. It will show you your data, okay, with all the variables. And then also automatically it will show the code. So the code will call the library. When we install the library read R, the code will show the library what's going on. It will call the library, and then it's using this function read underscore CSV. And this is your data that you are importing. And then this view is the one that is giving you that data here. And then this is the code. And then this triangle here is the import option. You can change the name of because this becomes what you'll be importing. But I always advise that the name of the data set, just leave it so it becomes the name of your data in RStudio. You have the option of leaving the first row's names. Some people remove them, but I would also recommend just to leave them there. And it gives you the format. We are importing comma separated values. And then you click on import. And then after clicking import, you'll see now on where the script's supposed to be, you now see the data by itself, okay? And then on the environment, it will tell you, okay, this data has 240 observations and 10 variables, data objects. And then everything that has happened, the operation that went on, it's going to be on your console. So basically, it load the library read R. They downloaded these data sets from your directory and name it crop recommendation, so that becomes your data sets, and tells you that 240 rows and 10 columns, and give you, okay, the type of data that you have, okay? Okay, so we're going to go and import these data sets, okay? So let's do it together. Okay. So this is what we'd like you to do. We have to click on import here. Okay. We're going to import the comma separated value. You click on this, and you're going to browse to your folder data science. It will bring that, and you're going to go and select. Oh, I think I don't have mine here. You're going to select the comma. I'm going to select this one here. You're going to select this one that you download, the crop underscore recommendation.csv. Okay. You select that and click import. Let me know if you have imported that one. Let me start again. Click on, go to environment, not history. Click on environment, import data sets from text read R. browse, and then select data, and then import. Let me know if you have imported that. Have you imported? Because I would like you to do that first because we're going to have an exercise. You can see many people have imported. Okay. Okay, so what I discussed was importing comma-separated values, okay? You can also import other formats. You can import Excel, you can import Stata, you can import SAS. So you don't have to have the same type of data format that you need, but you can import and then export in a different format, okay? So I'm going to go back here and show you in RStudio which ones import what, okay? So if you click on import, this one will import your text file. Please, do you still see my RStudio? You see my RStudio?
Yes.
Okay.
Yeah.
So the first one will import your text file. The second one will import your comma-separated value, CSV. The third one will import your Excel. The fourth one will import your SPSS. The fifth one will import your SAS. And the last one will import your Stata. So you downloaded these files here. You downloaded these files here. Number 2. I would like you, this exercise you're going to do in the class. I would like you to import this data here, CSV, and then import Excel, import Stata, import SAS, and import SPSS. Okay? So that's going to be the exercise we're going to do. So I'm going to go back to RStudio. You have all the files format, I think, except the text. Start with number 2. You're going to import comma-separated value. You're going to import Excel. You're going to import SPSS, SAS, and Stata. Okay. So let me show you the endings of the file. So Excel is obvious. This is Stata, DTA. SAS is obvious, and this is SPSS. So SPSS, Stata, SAS, Excel, and CSV. Okay, I'm going to give you at least the next 10 minutes to do that. Okay, just do it. Open your folder and make sure that first of all, go to your desktop, go to data_science, open your folder and make sure you have all these files downloaded from the link in Google Drive, because if you don't have it, then you're not going to be able to import them. So make sure the link that Peace gave you, you go and download all those files, put it in your data_science folder. After doing that, then you're going to import them in RStudio using the method I explained to you. Okay? So let's do that. Okay, before I forget, we had WhatsApp for data management. We're also going to create WhatsApp for data science. So I think tomorrow we should be able to bring a link for data science group. Okay? So I didn't want to forget that. And then also the notes, will be sending them tonight. And you'll get the notes tomorrow after creating the WhatsApp group. Okay? And then after every day, we'll be sending the notes after our webinar. So you bear with us. Okay?
I think my data sets are not accepting for Excel, SAS, and SPSS. I don't know whether it's the same with the rest.
Okay, can you?
Mine too.
So, okay, so I'm going to do this, but I'm not going to do it every day. Can you share your screen? I'm going to stop sharing. Can you share your screen? And take a look.
Yes. Let me share. Are you able to see my screen? Yes, Stephen, are you able to see my screen?
Yeah, I'm able to see your screen, but I want to see what's going on here. Why is it not able to open file? Okay, you don't have the files in your directory. You need to go.
I do.
So where are you?
When I try to import, for example, for Excel,
Okay.
when I browse to desktop,
Okay.
and then data science,
Okay.
and then the Excel,
Okay.
it brings this error. Unable to open file.
This is a valid Excel file.
It's the same thing with me.
I think everyone.
Same here. Same here.
You're able to open files?
Yes. And it's the same with
for the CSV, yes. But
what about
for
the
the
other
other files, they are not
Were you able to open
they
the
are
other
not
one?
supported.
It's only Start, I think, that worked, but SAS, SPSS, and Excel didn't.
So did you okay, you try SAS and I see try SAS. Yeah, that is okay.
SAS. Here
Okay.
we go.
Okay.
Unsupported features. File has unsupported features.
Okay. So I think I need to go and look at the file. That's okay. Thank you for sharing though. Yeah.
Welcome.
Can I ask something?
Sure.
Were we supposed to run the packages that you told us? Because you didn't mention that part in the packages. You told us to pick dplyr and on the others. We just stopped on.
That's a good question. You first installed those packages, didn't you?
We just transferred them to the what? To the top space of the console. I'm forgetting its name. Where we are looking at the data right now. I don't know if that could be that.
So when we did in the beginning, when I covered packages, you installed them.
We did not run them. You did not mention that, but actually, people in the comments were also asking, but it didn't come up at all.
Okay, so
install and load them, but it's still coming that way. It was installed and run, but you cannot load the data set. That is the problem now.
Okay, so what I will do, I'll go and look at the data sets. So tomorrow we'll try and see what happens. I'll go and look at the data sets, okay?
That'll be good.
I'll look at the data sets and find if there's a problem with the data sets. Okay, I will do that. Tomorrow I'll look into that, okay? Okay. So go ahead.
Do you mind maybe doing it on your laptop and seeing if it works on your side?
Okay, let me try.
Okay.
Stop sharing here.
And maybe when doing it, can you share the screen so that we appreciate whatever is going on?
Let me share my screen here. You see my screen? You see my screen?
Yes.
Yes.
Okay, I start with Excel. So these are the data sets, not so? Because when I did in the beginning, it was working. Maybe when I uploaded in Google, something happens because I tried when I was preparing the class was working. So which one is working? Stata only?
Yes, I think.
Stata is working.
It's only the read.
Mine, the rest are actually working except for SAS and Excel.
Mine is
One is CSV file.
mine only SAS, which is not working, but Excel.
I think across also CSV is working across, I guess.
So CSV work. Mine status working.
Yes.
Mine status is working. I need to go and find out what happened because we uploaded them on the Google Drive, And by the I'm using sometimes when I'm using Mac, sometimes things happen, but I will make sure that by tomorrow I'll find out what's happening because it seems like it's not.
I've also observed that your data set is different from ours. Ours, that of the Excel doesn't have the file extension. So I don't know whether that might be the reason.
Which one?
The Excel data set doesn't have the XLX file extension for our data set. The one we downloaded from Google Drive.
Maybe let him try importing Excel file. Let's see. Let's just go through it. Excel and see.
So this is Excel, not so?
Yeah,
yes,
you try.
But ours doesn't have the extension.
This is XLS.
Yes.
That's Excel, yeah. This is Excel. Because I uploaded and then I downloaded. When I created my data science, data_science. So I'm going to go through tonight and see what's going on, okay? With the files, okay?
Yeah.
Yeah,
Doctor, that would be
tomorrow we'll start from there, okay?
Wait,
Can you hear me? Hello?
Yeah, doctor, you do it.
I'll do it tonight and see what's going on, okay?
Yes, doctor.
Okay, doc.
So I will that one we'll cover that tomorrow. We'll find what the problem is. So basically, some are working, some are not working.
Yeah.
Okay, well, I'll find out what the problem is. Okay, can we move on?
Maybe it's because of the packages in our computers, they're not compatible with the SAS.
I'll find out, okay? But it's not supposed to, because ARA is, it doesn't have to, even if you don't have SAS, it's supposed to work, but I'll see.
All right.
Okay. So we're okay here, we're okay here. That's where we were. Okay, so I'm going to show you a few things about data structure. After importing your data, there are a few things that we can do. Let me see that. Let me go back and see if I can, the one that I'm able to import. I think I was able to import data, wasn't it? Yeah. You see my screen? You see my ARA Studio?
Yes, yes.
So after importing your data, there are a few things that you can do. This command here, this view here, it's already pre-written in ARA Studio, but this command here will display for you the data. So let me first remove this here. So if I type you see, it brings for you the data, so you can inspect it from there. Another thing that you can do, you can see the structure of your data, and the command is str. Okay, so this will give you the structure of the data. For example, this is too long, but okay, NDVI is numeric, rainfall is numeric, temperature is numeric, humidity is numeric. Most of them are numeric, but if you look up crop yield class, is character, Brucellosis is character, and so forth. So that's, you can see the structure of your data before you work with. And then if you want to see the first 6 rows of your data, use the command head and then the name of your data set. Okay. So you give it the first 6 rows. So you can see also it gives you the structure. And then if you want to see the last 6 row, use tail. So this is the last 6 row of the data sets. If you want to see the first 20, you do head. So this will be the first 20 rows, something like that. We'll cover more with Peace tomorrow with working with data, okay? So that's about data, about how to maneuver that. There are very many ways of doing that, but I want to show this briefly here. So now I'm gonna go, I think, and finish the last part of our webinar today. It's about exporting data. So if you import your data, you can work with data, you can subset them, you can change a few things in there. It's part of data science. That piece will cover with you starting tomorrow. But after that, you can also export the data, okay? So you can export this data in Excel file, in Stata file, SPS, and SAS, and so forth. To export your data, use the write command, okay? So for comma separated values and SAS, Stata, SPSS, you use the same library. So this library is for comma separated. This library is for SAS, SPSS, Stata. But for Excel, you have to install another library called write.excel. That's what we install. When you're reading, use read.excel, but when you're writing, you have to call this library here, okay? So what I would like you to do, I would like you to call this, first of all, read this data sets. I think this data set, I think you guys were able to read it. Crop underscore recommendation. Were you guys able to read that one? In comma separated value.
Yes.
You're able to read that, not so? So what I would like you to do, I would like you to go back to your R Studio, read this data, okay, in CSV format. And then after reading it, we would like you to save this data. Don't save it this one because you're going to replace it. Save it in crop recommendation _1 CSV. You're going to save it in Excel using this command. You're going to save in Stata using this command. You're going to save in SPSS using this command and in SAS. But you have to call the library first. So let's go back to our SAS, our R Studio first, okay? So what we're going to do, we're going to have it somewhere. You have this in your data science, not so? Data underscore science folder. You have this one. I want you to import it. Are you with me? I want you to import this. After importing it, you're going to use this script here. You're going to write library read R, library read Haven, library write Excel. And then you're going to write underscore CSV, crop underscore recommendation, comma, crop underscore recommendation underscore dot CSV. And then you're going to enter. That will save your file in CSV format in your folder. Next, you're going to write underscore XLS, crop recommendation, comma, crop underscore recommendation underscore 1.xls. And that's going to save like, so you're going to do all the four. Are you with me? Put yes if you're with me.
Yes.
Okay. We're going to load our crop recommendation. And then I'm going to leave this here. You're going to do this. You're going to type by yourself. You're going to type library read.r, you're going to enter. You're going to type library Haven in console, you're going to enter. You're going to library write Excel, you're going to enter. Then you're going to write underscore CSV, open bracket, crop underscore recommendation, comma, double quote, crop underscore recommendation underscore 1.csv close, and you enter. That will save it. You'll save the first one to your data underscore science folder. After that, do the second one, enter. The third one, and we should be able to get something like this in your what? Data underscore science. So that will be our last assignment for today. And then when you're done, there's an assignment for take home that will, Peace will put it on the chat for you to do tonight. So guys, okay? Just put a yes if you understood what I've explained to you guys. So we're going to import crop underscore recommendation. That will be our data set. We're going to export all in all these 5 formats. And we're going to name it crop underscore recommendation -1 dot, depends on what you're going to do. And that will bring us to 5. Let's do it.
A question, Doctor.
Go ahead. I'm listening.
Yes. Are we writing this on the in the console or
in the console? Yes. In the console,
Okay,
not in the
fine.
script. That's why you do library read. You enter using your keyboard in the console.
Not in the script.
Not in the script.
Okay.
Today
fine.
we use only console.
Okay.
Script will start from tomorrow. Today we're using only console.
Okay, fine. All right.
Yeah.
One question, Daktari.
Sure.
Yes, on the part of enter, the execution part, do we just click enter or
you type
we
enter,
run?
you enter on your computer, enter. Just type enter. You type that and you enter that computer. On Mac, it's called return. In Windows, is it, how do you call it in Windows? I'm using Mac. That return. When you type something on computer, you want to go to the next line. You get me?
Yeah, okay.
Okay, so let me, so I just want this to be, so you can see what you're doing.
So, Doctor.
Yes.
Please, can you do a demonstration of one so that we can see?
Okay, let me do one, okay?
Yes, please.
Okay. Okay, I imported this recommendation also, this one. So I'm going to start with the first one. Let me clear my console. So I'm going to do library read error. Enter. Okay. Right. Underscore CSV crop recommendation comma crop underscore recommendation underscore 1 dot CSV. Enter. Okay. So I've done for you the first one. So do the last 4. I'm going to go back and show you the slide. So you have to do this. You have to do library heaven, enter. You have to do library write.excel, enter. Do these 2 before you do the rest remaining. Type library heaven and enter. Type library write Excel and enter, and then do write this one here, write this one here, write this one, and write that one. Okay?
Dr. Steph?
Yeah.
Yeah, so as the others are doing, I have noticed that on the last line, so the command is write underscore XPT, or at the end is .sas. Well, for the rest of the commands, what is after write dot underscore is the same as what is after the dot at the end. Why is the last one different?
That's a good question. Somebody wrote the package, so they chose that.
Okay, thank you.
Somebody wrote the package and they chose that. Please, can you share the link for the data download? Thank you. So the file here, somebody asking the file downloading. These are the files you're supposed to download here. These are the files you're supposed to download, but we had some problem with the files. So we are going to look at them tonight and see what the problems are. So right now, don't worry about them because some are being important and some are not. So we would like to go and see what happens to them. Okay? But the first one is okay, and the last one is okay, but this one's number 2. Okay?
Can you please display your the where the taxes, the last one, the last command?
The last command?
Yes, the last one. Okay, okay.
This one. Please can you share with them the link for the quiz for homework? It should be the last slide. And also, Peace has put a WhatsApp group for data science. So if you can click on that to be able to join. We'll put them again like tomorrow, if you can do that. So she has put the link for the WhatsApp. You can click on that, be able to join, and then the link for the day for the data. Someone say the files can be displayed in the project. That means you're not exporting the file. They have to be, it has to be displayed like mine here. If you're not being displayed, that means you're not. Okay, you go to your folder and click on, and you see if they're there. Peter, you click on the folder on your on your desktop and see if the files are there. Okay, so then you're importing the crop underscore recommendation dot CSV. If you import that one, and then after importing, then you start exporting the rest. Because you need that file to import it first, crop underscore recommendation dot CSV. Okay, thank you. So tomorrow, we'll repeat this again tomorrow, since we're running out of time. We'll go and work on the data sets, and we'll start with the importation of data sets, and then we'll finish up with this tomorrow before we continue, okay? So we're going to do that tomorrow in the afternoon. That will be the first thing we'll do. Those files that we're not able to import them, we'll work on that tonight and see what the problem.
So, Doctor, please, I want to understand one thing.
Pardon?
I said, please, I want to understand something.
We want to do what?
I want to understand something. If you
Sure, go ahead.
save the file in the CSV for my crop recommendation underscore, where do you locate it?
You were supposed to download it from the Google Drive that Pete shared with you.
Yes.
And put it on the data underscore science that you created. It's a folder on your desktop.
Yes, I had it in the folder.
Okay, then you have to go to File.
Okay.
Let me show you here.
Yes, please demonstrate on the screen. Let's see, because I tried doing this, I'm not seeing it.
Oops. You see my screen here?
Yes, I'm seeing your screen.
You see my RStudio?
Yes, I'm seeing the work environment.
So you click on this, you browse, and mine was here. You see this?
Yes.
You click on that, and then you import. And then after importing, you already have that. And then start exporting. It's already there. Are you with me?
So I want you to go on the console here. Under the console where you get a library read. So is that where you're just going to run and then it will save? I just want to know how it will be saved, how the next file will be saved.
So where the next file will be saved is this one here. You see my slides?
Yes.
But it's using this one, right? Right underscore CSV. This is a function. And you type the name crop underscore recommendation.
Okay.
That's the file you're going to save. And then you give it a name. You're going to save it as crop underscore recommendation underscore one.csv.
All right.
And that should go to your data underscore science. Make sense?
All right. Thank you.
Okay, thank you. So I think we have run out of time, and thank you very much. So let's pick up tomorrow, and we'll start with data importation, and then we'll finish up, and then Peace will pick up from where we stop tomorrow. David, back to you. It's David here. David, you're muted, I think. Okay, I'll see you guys tomorrow, okay? Have a wonderful evening. Bye-bye, everyone.
Bye-bye.
Goodbye. Goodbye.
Is Space still around?
Yes, it's Joram.
Hey.